Good morning, everybody, and welcome to SciTech. I'm Clay Morey. I'm the new CEO of AIAA, and it's my pleasure to welcome you all here to sunny Orlando, Florida, for the 2025 AIAA SciTech Forum. We're thrilled to have you guys with us here this morning for this event. It's great to be part and back with the AIAA family and not in the snow in Washington, D.C., so I'm glad to be here and have gotten out of town before Snowmageddon hit again in Washington. Now, you're part of the largest event for aerospace research and development this week, and I'm excited to announce that we've broken the 6,000 person attendee mark, so you're now here this week with 6,000 of your friends for another exciting SciTech. So we're setting records this week, and we're proud to have you guys here as part of this outstanding event as we build momentum going into the year. And now I look at this room, and just walking around and meeting a number of the students that are here with us, you can feel the energy, and it's clear that our community is coming together to drive innovation and connection and creating technical exchange. So thank you for coming this week. Is this the forward one? All right. Just working on the tech here. So SciTech is known for setting the tone for the coming year. What's exciting for me is to realize that the knowledge shared this week is going to lay the groundwork for future technology advances. And SciTech creates a unique atmosphere that inspires innovation. And I'm looking forward to experiencing my first SciTech Forum with you as AIAA CEO. And many of you here, I know students, we have over 2,000 students and young professionals here this week. It's their first SciTech as well. So I encourage you to see them, meet them, and we've told them that last night at our introductory session, they should be looking to connect with you, link in with you, and so please do that as you meet a lot of the students and YPs that are here this week. Today marks my 100th day leading the Institute, and so it's been an exciting first 3 months. I started in the beginning of October leading AIAA. By the way, I'm a lifetime member, and this past year before I even interviewed for the job, I was recognized as a fellow. So I've been a long-time supporter of the Institute and let's say somebody who volunteers a lot for different organizations, but it's great to be now in the role leading this organization. I'm excited to be part of it. I've been meeting with the team for the last 100 days, and we're trying to figure out how to chart our course for the future of the Institute. I've already had the opportunity to travel a bit. I've been out to see the Rocky Mountain section. I've met some of the student branches out there. I got to tour Lockheed Martin, Boom Aerospace, and it's been great to meet our members, to see the excitement out there. And I'll tell you, for me, this is the most exciting time in aerospace. I've been working in this sector for over 32 years, and now is the most exciting time. When you look at the technologies and advances that are happening right now, from air mobility to space, catching rockets in midair, landing reusable boosters, air mobility, this is the most exciting time. So we can feel that energy, we can feel how we're advancing as an industry, and the Institute's right at the forefront. We're on the tip of that spear, leading that innovation, so I'm glad you're here with us today. You know, 2031 will mark the Institute's 100th anniversary, so we're rapidly approaching 100 years for AIAA. And as I begin my journey, I'm looking forward to charting a path to innovate and expand the Institute, making sure that we're relevant to all of you aerospace professionals for the next 100 years. Now, I won't be around for 100 years from now, but we have to make sure that we chart that course and that we're clear in terms of where we want to head as we look to communicate in different ways. You know, I grew up in an analog world. We're now in a digital world, and the young professionals today are looking at societies and sharing information in different ways that I couldn't have imagined when I was in my 20s and 30s. So we need to figure out how we're going to continue to attract, recruit, and retain those new members over the course of their career arc. So my other task is to harness the collective energy of our volunteers. AIAA is an amazing organization because we have such a strong volunteer base. We are driven by all the folks here that are here in this room that are writing papers, that are chairing our committees, that are leading this organization forward. And so, look, we're honoring the heritage of our institute. We're refining our member services. We're going to look to figure out how we can continue to grow this organization from 30,000 members, let's say, to maybe doubling that number over the next 5 to 10 years. So we're excited about that. I know the institute staff is excited about how we can think about growing the organization, and you'll see a lot of changes coming in the next couple of years where we're going to chart that path for the future. So we look forward to working on that with you, all of our members. And if you have feedback for me, it's Clay at AIAA .org. Don't all email me right now because I'm at the conference, but wait a day or two and get back to me. And I would love to hear your thoughts about how we can chart a course for the Institute for the next decade and next 100 years, next century. One highlight for me this fall has been visiting those corporate members, going to Lockheed Martin's factory, see the GPS satellites, visiting the F-35 facility down in Fort Worth, Texas, visiting Boom Aerospace and other. I got to see Electra the other day as a great tour to look at their aircraft development program there. Look, all of that support is meaningful. We have corporate members that really help to drive this institute forward, and they're the ones that make forums like SciTech happen. So without their support, we wouldn't be here today. We wouldn't be able to grow this organization. So their collaboration and generosity have made this week possible, and we appreciate, so I'm going to read the list here, our executive sponsors, Lockheed Martin, GE Aerospace, Northrop Grumman, RTX, and today's session underwriter is L3 Harris. Thank you, L3 Harris. Our sponsors, Bastion Technologies, Florida A&M University, and the Florida State University College of Engineering, L3 Harris, Stell Engineering, the University of Illinois, Urbana-Champaign, and to our media sponsor, Aerospace America. Please join me in thanking them for their generous support. And I'm especially excited to welcome all the students here. I mentioned a little bit before. We have 13 of our rising stars in aerospace with us today. We met with them last night. These young people are from a group of underrepresented university students who have an interest in pursuing a degree in aerospace. They hail from 11 colleges and universities across the United States, so welcome to our rising stars. Thank you for joining us. They get 1 year of free membership, by the way, in AIAA, so we hope that they come and they stay with us through the course of their career. All week, they're going to be listening and learning. They're going to be attending your sessions, technical sessions, and they're going to be meeting you in the hallways and connecting you, and we look forward to their bright futures with us in the aerospace sector. We're honored to be a part of their journey from the classroom to throughout their career, and because 7 of these students that are with us today from those rising stars are first-generation college students in their families, and so we're glad you're here. I'd also like to recognize the students attending the International Student Conference with us this week. By the way, of our 30,000, roughly 30,000 members of the organization, 9,000 of them are international. So while we're the American Institute, the first day in AIAA, we're actually very much an international organization, and we welcome all of our international guests. The student conference is bringing together students who won their regional student conference categories in the past year, and thank you to the AIAA members and individual donors who have given to our AIAA Foundation, and our foundation chair is here, and Laura's going to tell me that please keep giving to the AIAA Foundation. It's important. I know I give, and we set some new records this year in terms of donors, and it's because of that generous support that those students are here with us today, so thank you. Today we welcome 30 teachers as well for our educator workshop. And AIAA believes that teachers are actually vital members of our aerospace communities, starting K through 12, but university and going through the graduate level. We're grateful they're here at SciTech as we dive into STEM concepts for the classroom and out-of-school time activities. We are excited to be inspiring, that they are inspiring so many young minds that are here, and they're going to grow up, and these students are going to grow up and tackle many of the new challenges that are going to be facing us in the aerospace sector. So thank you for joining us. Our theme at SciTech this week is Energize the Future. And you will hear about breakthrough science, revolutionary new technologies, and next generation aerospace capabilities. And these insights are coming from speakers and panels that will fuel and move us forward boldly. To use a Star Trek reference, we're going to move forward boldly and as we try to explore new technologies going forward. This week's high-level programming focuses on 5 key themes: aerospace technology needs, design and development, hardware trends, software and emerging artificial intelligence, AI, and the future of aerospace. I'd like to thank the Guiding Coalition for building this outstanding program. These are AIAA volunteers that have devoted countless hours turning their vision into reality for the next 5 days here in Orlando. You will have a chance to meet many of them throughout the week, and they are truly shaping the future of aerospace with this program. So the Guiding Coalition has been led by our AIAA Aerospace R&D Domain Lead and SciTech Executive Producer, Greg Zacharias. Greg, I'd like to thank you personally for putting this together. Fantastic job. And thank you for the leadership in the R&D domain. So I'm going to thank all of the leaders, bear with me for a moment, that helped Greg in planning this forum this week. So we have Tom Cooley from TC Space Consulting, Matt Cribb from Anduril Industries, George Edelberg from TU Delft, Harold Enuat from Carnegie Mellon University Software Engineering Institute, Taylor Fazzini from Northrop Grumman Aerospace Systems, Steve Frick from Lockheed Martin Space Advanced Technology Center, Mike Hernandez, GE Aerospace, Brian Kowalczyk, University of Cincinnati, and I met a number of our University of Cincinnati Bearcats here. Thank you guys for joining us. Samantha McGill, NASA Langley Research Center, Tom McDermott, Systems Engineering Research Center, Charles Norton from NASA's Jet Propulsion Laboratory, Masami Onada from JAXA, the Japanese Space Agency, Wally Orisimulu from Pratt & Whitney, Venkesh Sankaran from Air Force Research Laboratory, Esther Varga from Honeywell, Marilee Wheaton from Aerospace Corporation, and Kayla Zweifel from BAE Systems. Thank you all for your help in putting this program together. It's a lot of hard work and they do it for free, so really thank you very much. We have an outstanding volunteer army. Our technical program is one feature that sets the AIAA Forum apart from other events in this industry. We're not just a trade show, right? This is a technical forum. We're driven by our technical committees. The content here creates the technical papers that go into our catalog, and that's what drives this institute forward. We are the thought leaders in this industry. You are collectively the thought leaders in our industry, and this is what makes our institute hum. So we're glad you're here. We look at deeper research and technologies geared to solving the specific problems facing the aerospace community. So just to give you a snapshot, this week's program features 770 technical sessions with nearly 3,000 technical presentations. That's an amazing amount of content, and that's the engine that drives the Institute forward and our industry forward. Congratulations to all the authors on your accomplishments, and look forward to presenting your manuscripts this week. We're grateful to the group of volunteers who curate our technical program, who review those abstracts, do the peer review, that are creating the sessions, and to chairing those sessions. The SciTech Forum would not happen without you, so all of you that are here today, thank you for doing all that work and driving us forward. Last but not least, I want to thank our technical chairs, the technical program committee for their outstanding efforts. Please find all their names, I won't read them all, that are listed in the back of the program. Thank you all. And before we begin this week with our remarkable Monday morning plenary speaker, I want to share with you what I'm looking forward to experiencing this week. Today, we get to recognize dozens of our AIAA members with prestigious awards and the Best Papers honors. It's going to take place here back in this room at 5:30 p.m. for the awards recognition ceremony. Please come back, support them and your colleagues in the industry so that you can see them recognized here on stage. And tomorrow we're going to open the expo hall next door, and you're going to get to see innovation on display. I'm hoping to see many of you at the reception there on Tuesday evening, which will invariably spill out into the lobby area. We're going to make sure it's not too tight this year, and it should be a lot of fun. The other thing I'm looking forward to, by the way, is Blue Origin's going to help us celebrate SciTech this week with a New Glenn launch. I think right now it's scheduled for 1 a.m. on Friday. If I look at the NOTAM notifications, nothing's out formally yet. But thank you, Blue Origin, for launching on our week here. And maybe some of you can stay over and go down to the Cape and watch New Glenn lift off from Launch Complex 36. Should be tremendous watching that large launch vehicle with 3.5 million pounds of thrust. I used to work for Blue Origin, so a little commercial. 3.5 million pounds of thrust, watching that baby lift off is going to be something to see. So if you get a chance, head out to the Cape. I know it's going to be early in the morning, but give it a shot. One fun note this week, we've designated tomorrow as Wear Your Team Colors Day. So we encourage you to wear your gear or colors from your favorite team. Could be your professional team, your alma mater, your college team, your rec league. Doesn't matter, wear your colors. If you got them with you, go buy a jersey if you don't have one, and it'll be fun to see that tomorrow on Tuesday. Now it's my pleasure to welcome Dr. Charles Norton, our Guiding Coalition member from NASA's Jet Propulsion Laboratory, to come to the stage and introduce this morning's speaker. Dr. Norton?
Hello, everyone. Good morning. It's so good to see all of you again here at SciTech, and it's my pleasure to welcome our keynote speaker. So we're very honored to have my leader and personal friend, Dr. Laurie Leshin, director of NASA's Jet Propulsion Laboratory, to join us for the kickoff. She served as JPL's director since 2022 and is the first woman to hold this position. She's a distinguished geochemist and space scientist with extensive leadership experience across academia, government, and several NASA senior leadership positions. Laurie was president of Worcester Polytechnic Institute from 2014 to 2022, and she has previously served as Rensselaer Polytechnic Institute School of Science Dean. She has many honors. Just a few of them include NASA's Outstanding Leadership Medal, the Distinguished Public Leadership Medal as well, and the Meteorological Society's Near Prize for Outstanding Research by a scientist under the age of 35. And I'm sure you'll see she hasn't aged much since then. So I think you'll be very pleased and agree with me that we couldn't have found a better person to kick off SciTech and our theme of aerospace technology needs. And once Laurie's concluded her remarks, I will join her here on stage and we'll take questions from you. So please use the QR code to upvote your questions. So now please join me in welcoming Laurie to the stage.
Perfect. All right, good morning, good morning. How are we doing? Let's see, let's get the slides moving here. All right. Oh my gosh, so many people in the back. Hey, raise your hand if you have an open seat next to you. There's tons of open seats right here. If people want to come forward, raise your hand if you have an open seat next to you. There's a lot of places to sit if folks want to try and come in. Because I've got about 3 hours worth of slides here. No, I'm kidding. I'm just joking. All right. Good morning. Happy New Year. Happy New Year. It's great to see everybody here. I just came back from vacation, which is why I forgot how to hold a clicker. And it's wonderful to see you all. Welcome to SciTech. It's a thrill to be here to get to talk a little bit about the work that we're doing at NASA JPL every day to try and push the boundaries of scientific exploration, robotic exploration, doing what we call daring mighty things together. So just to get us started, just to get us warmed up a little bit, here's a little video summary.
In preparation for parachute deploy. Factory maneuver has started. Touchdown confirmed.
All right. So you can see the kind of amazing work that we get to do each and every day at JPL, and it really is an organization, and I'm just going to be totally open here. I'm going to brag on us a bit today. It's an organization that's pretty uniquely positioned for innovation. NASA obviously has innovation all over its mission, but JPL is a little bit different than all other NASA installations. We're unique within the agency. We're what's called a federally funded research and development center. We're not government employees at JPL. We're operated by Caltech, one of our nation's leading and most innovative universities. We're operated by Caltech for NASA. So we have this unique combination of sort of government infused but privately run. And so it provides an opportunity for the government to get long-term advice, long-term R&D from folks that are outside the government. And so it's a great model for innovation for the future, and we're really proud to have this unique position within the agency. And the way we apply that is to big questions, big scientific challenges, huge opportunities that can be addressed through robotic space exploration. And when we look to the future, when we ask ourselves sort of what are the big things we're up to, what are we about, I think of it in terms of 3 questions, and they are some of the biggest questions that we can ask as humanity. What is our destiny here on Earth? How is our home planet changing? How can we make sure that humanity thrives on our planet? So we'll talk some about that. Are we alone? Perhaps the biggest question that we can ask as human beings, is there life out there? So we'll talk some about how we're answering that question. And finally, how do we lead the future? What is important as we look beyond today to tomorrow? And that's really well aligned with SciTech's theme. So I'm going to just jump right into it and share some of the amazing things that we're working on to address these big questions. So starting with Earth, starting here at home. I think most people know JPL is the place that does cool Mars rovers and deep space exploration. And yes, that absolutely is our history. We're proud of that. But we also have a hugely long, decades-long history of contributing to our understanding of our home planet. So just to give you a few examples of the kind of things that we're working on. The first is understanding how our atmosphere is impacted by things like pollution, methane superemitters. So methane, not only is it responsible for 30 to 40% of greenhouse warming, but it also puts pollutants into the atmosphere. It costs oil and gas companies $1 billion a year in lost revenue when they have a leaky pipeline with methane that you cannot see with your eyes, but we can see it now from orbit. Very exciting recent results from EMIT, which is attached to the outside of the ISS right now, and future missions as well, looking to track this important gas. Oil and gas companies want to fix these leaks when they happen. We now can track them from space and help not only pull pollutants out of the atmosphere, but actually help companies be more profitable. So it's really a win-win. And doing this with incredibly sensitive spectrometers from space, these innovations that were developed right at JPL. So that's exciting. More challenges for humanity on Earth that we're helping to address. Also, in this case, from the ISS, a different instrument, in this case, a thermal infrared spectrometer set of radiometers that are looking at, actually it was designed to look at evapotranspiration and the health of vegetation, which it does and helps to predict fire danger based on how healthy the vegetation is. Unhealthy vegetation, more likely to burn. But it also is helping us do things like deal with heat island effects. These are huge challenges in urban centers as they've grown, and I love this example. This is actually from LA, looking from the space station down at LA and mapping the city, and you can find heat islands within even big cities. There are places that are hotter. We did this experiment with a local organization that was interested in combating heat island effects. And so we found this very interestingly, and you can see it on the right side, curved street called Stephanie Drive. And they coated it with a very inexpensive coating to help mitigate the heat from the asphalt. And you can see from orbit, we can pick out Stephanie Drive there and see by a couple of degrees, it has actually cooled this neighborhood. And if you talk to the people in this neighborhood, they will tell you they can tell the difference from this. So incredibly, in some cases, straightforward and easy mitigations. Our friends in the city of LA, he calls this his $8 million slide because he's been able to raise so much funds to be able to help combat urban heat islands. And we're doing this from space, from Again, an instrument bolted on the outside of the International Space Station. Flooding, water, Earth's water, that's really life-giving for us, right? We need to understand how Earth's surface water is changing and evolving. We're doing that with a mission we launched a couple of years ago called SWOT, Surface Water and Ocean Topography. It is a radar interferometer that for the first time, not only is it allowing us to map the ocean surface water height in unprecedented detail, but it's allowing us to look at water on land, to look at fresh water and understand how it is distributed, how it's changing, and what happens in the case of flooding. We can now track how rivers and lakes respond to flooding events that allows scientists to better predict in the future flood risks. By looking at things like the slopes of rivers and how they respond during floods, we can better predict that future impact of flooding. And so it allows us to, again, flooding is a huge impact as Earth's climate is evolving, and we need to understand how to best protect coastal communities, communities in floodplains. The whole definitions of floodplains are changing, and space-based observations with radar are helping us do this in unprecedented detail. Like most of our missions, SWOT is an international collaboration. I should mention our great collaboration with the French space agency CNES over many years of looking at the oceans and now mapping millions of lakes and rivers on land every week. And we can measure their heights to better than an inch. And speaking of measuring heights well, our next mission to launch in the earth science realm will be this spring. It's called NISAR, and it will be doing what SWOT is doing for water, NISAR is doing for land. We'll be looking for tiny changes, centimeter scale changes in the height of the land through two-band SAR, two-band radar. So it's called NISAR, this mission, and now y'all get to become the insiders for this, right? This is a real NASA mission because it has nested acronyms. The N stands for NASA, NISAR. The I stands for ISRO, the Indian Space Research Organization. It's the first major collaboration between NASA and ISRO on a mission, and it's really almost a 50-50 split of this mission. We're so excited to be collaborating with our colleagues in India. So NASA, ISRO, synthetic aperture radar, NISAR. So now you've got the insider scoop on the nested acronyms. And so it's going to be sending two different long wavelength bands of radar to look at very small changes in Earth's surface to do things like, one of the great applications of this is to help us prepare for disasters. SWOT is helping us with flooding. NISAR will help us with things like volcanoes, earthquakes, and landslides, understanding how Earth's surface is changing. It can also measure changes in ice sheets. It can measure changes in biomass, above ground biomass, forest health. And so NISAR is going to give us unprecedented eyes on the surface of the Earth. So watch for that. It launching, we think, around the end of March, beginning of April, from India. So very exciting. So to keep our eyes on NISAR. So with our Earth science work, we are not only understanding our planet, but trying to make sure that we who live here have safe and productive and healthy lives on this big blue marble that we are living on here in space. And we're really proud of this work that we do in understanding our planet and helping our communities prepare for different kinds of challenges that they face. I'm going to switch gears and talk about this big question: are we alone? You know, in some ways, I like to say we're in a space race with ourselves in trying to answer this question: are we alone? How are we going to figure this out? Where are we going to find that first evidence of life elsewhere? Is it going to be on Mars? Is it going to be on one of the moons of Jupiter or Saturn, Europa or Enceladus? Or is it going to be on a planet orbiting another star, an exoplanet? And the truth is that we are working on all of those avenues of answering this question. And I truly believe, especially for you students in this room, during your professional lives, we will answer this question. We will get that definitive evidence. May not be of little green women But the idea of finding even simple life elsewhere, the idea that life starts on planets or moons elsewhere beyond Earth would be so exciting. And I believe we're on the path to make that discovery. We don't have that data yet, but we're on that path. So I want to give you a little bit of a sense of where we're looking. So just to hit those three areas I mentioned. So if you look at one of the most exciting things that's happened during my career, now long career, is the discovery of planets around other stars. We knew planets should form as part of how solar systems form, but we didn't have direct evidence that those planets existed. Well, we do now. We do have evidence that those planets exist. And you can see here over the last 20 years or so, the places, the stars in our galaxy where we have found exoplanets, and you're about to see pop up a big concentration of them, a part of the sky where our mission Kepler just stared for many years and found lots and lots and lots of exoplanets. The challenge with these exoplanets is we don't detect them directly. We actually mostly detect them by the impact that they have on their parent stars. Either we see that their gravity is shoving around those parent stars and we can measure that, or that they go in front of or behind their parent star and we can measure that slight change in brightness of the parent star. So we're using the star to detect the planet. You can see Kepler's field of view there, that sort of little plus sign. That's where thousands of the exoplanets have been discovered, and we're now up to over 5,500 exoplanets. This is now a couple of years old. So what we want to do is to be able to detect and sense and analyze the light directly from the planets themselves. That's really hard. It's hard because the stars are really bright and the planets are really dim. So that's a tough optical problem. We're going to take a giant leap towards solving that problem with the Roman Space Telescope and its coronagraph instrument, which we just delivered a few months ago to NASA's Goddard Space Flight Center. This thing, which is about the size of a grand piano, so it's a big, complex set of deformable mirrors and filters and detectors, one of the most complex optical systems ever built, so that which is, by the way, it's 100 to 1,000 times better than any coronagraph ever built, so 2 to 3 orders of magnitude improvement. It can detect things that are 100 million times fainter, planets that are 100 million times fainter than their stars. 100 million times. And so with this coronagraph instrument, and here it is, by the way, there's the grand piano, which just a couple of weeks ago was integrated with the telescope there at NASA Goddard. If anyone's in Maryland, you should go see the Roman telescope. It's being integrated right now. We're so proud to have this instrument built at JPL on board now. It will allow us again to see planets that are 100 million times fainter than their star. That allows us to see Jupiters. So we will be able to see sort of gas giant type planets at gas giant type distances from their stars. It's a huge leap. We'll talk later in the future about the next huge leap that's needed. But we will be making incredible advances. We'll be sensing the light directly from dozens to hundreds, even thousands, I hope, of exoplanets once Roman launches in a couple of years. Our next target in our quest for discovering whether or not we're alone is an ocean world like Earth. Probably the best chance for us to find life today, something living today in our solar system, are ocean worlds, and the best one, we think, is Europa, a moon of Jupiter. And so we just launched, the last time I was in Florida, well, there was a hurricane first, and then we launched Europa Clipper, and so here's some video.
Space Center for NASA's Europa Clipper mission, a nearly 2 billion mile, 5.5-year journey to Jupiter's icy ocean moon.
And liftoff. Liftoff, the Falcon Heavy with Europa Clipper, unveiling the mysteries of an enormous ocean lurking beneath the icy crust of Jupiter's moon, Europa.
There's our team back in Pasadena.
Side booster separation confirmed.
Fairing is separated, and those will be recovered by SpaceX's own recovery ship, Go Cosmos.
This is a big moment for the program, for NASA, APL, and JPL. Let's watch.
Europa Clipper, separation confirmed.
And there you go. NASA's Europa Clipper probe, embarking on a long-awaited mission to study Jupiter's icy moon Europa. And what a sight!
Now they wait for acquisition of signal.
And I believe we have it. There it is. Confirmation of signal from the spacecraft Europa Clipper.
So that was just 2.5 months ago that we launched Europa Clipper on a Falcon Heavy. Thanks for the great ride, Elon. We love that. Perfect injection. It is on its way, its first big event after getting all its solar arrays deployed and its various booms deployed. It's doing great, by the way. It's fantastic. It's flying beautifully. Its first big event will be a Mars flyby on March 1st. We'll have a couple instruments turned on, so we'll get a little data from that we can share over time. And then it comes back around Earth and then on out to Jupiter. So arriving in 2030, Jupiter's far away. One of the challenges with deep space exploration is you gotta be patient. I call these generational quests. The people who have been working on the idea of a dedicated mission to Europa have been doing so for more than 2 decades. Now they've got to wait another 5.5 years until we get there, but it's going to be worth it because the science will be incredible. So Europa, it's a ball of, it has rock in the middle, but the outside is water ice. It's very cold out at Jupiter, so the surface is icy. But because of Jupiter's intense gravity, as Europa goes around Jupiter every 3.5 days, it's squeezed and squeezed and squeezed. And that energy leads to that ice being melted and being a global ocean of liquid water. We think there are 2 Earth oceans worth of liquid water on Europa. And that probably beneath that, there are some volcanic activity that could be driving hydrothermal vents like we see at the bottom of Earth's oceans. Those are great places. We think it probably has all the ingredients for life to have gotten started. And the question is, did it? Now, will Europa Clipper be able to sense that from multiple close flybys, that it'll do 50 flybys? Maybe, maybe not, but it will help us really assess the habitability of Europa, understand the thickness of that ice. Are there places of that ice that the ice thins out such that we might, with future missions, and again, we'll talk about this in the future, be able to access that ocean? And if there are geysers and things, we'll be flying through those and tasting the water and the hopefully organics coming out of there and being able to assess them. So it's going to be an incredible opportunity to understand this ocean world, the only other global ocean world really that we know of in our solar system. It's going to be extremely exciting. So Europa, we've got exoplanets, we've got ocean moons, and we've got our neighbor Mars, which again, today is not a very hospitable place, but we know based on the thousands of dried up lake and riverbeds that in the past, at the time that life was emerging on Earth, Mars was a hospitable place. It was a habitable environment. The question is, was it ever inhabited? And that's really what we're trying to find out with our Mars missions that have increased in complexity over time. You all remember the cute little rover, right? Actually, you students are too young. Spirit and Opportunity, and now our really car-sized Curiosity and Perseverance, still today exploring the red planet. And now we've got a new way of exploring from the air. Very exciting. And of course, the future, and that'll be a fun thing for us to talk about, is there going to be more Mars in our future? I think there is. It's going to be very exciting. So today we have Perseverance. You all remember we started with that tiny little rover, the one that Matt Damon went and found in The Martian. You all remember that, right? Today, our rovers are car-sized. That's the sort of orders of magnitude growth in landed mass, in capability, in science that we have achieved over the last 2 decades on the surface of Mars. And today, we are there with Perseverance. Today, as we speak, has just exited the crater it landed in after collecting some incredible samples there, and is now up on the ancient plains of Mars collecting more rocks, each one about the size of your pinky. And they are being stored in the belly of the rover in these wonderful tubes. And our job now is to go get them. Because in order to answer this question about are there signs of ancient life in Martian rocks, we have to get those rocks in Earth-based laboratories. And that's why we want to go to Mars and bring those rocks back. That's why we're collecting them, not just analyzing them in situ, but actually collecting them. That's what a geologist does. They go in the field, they find the most interesting rocks, they throw them in their backpack, and they bring them back to the lab. That's what we want to do with MSR. And in fact, recently, in the last few months, we've collected by far, well, not by far, they're all interesting. I love all my rocks equally. I'm a geologist, by the way. I'm a Mars geologist, I tell you that. Okay. But this one is particularly special. A few months ago, we found this rock, and you can see it on the left there, that has these sort of leopard spot looking things that seem to be there's evidence of water in this rock, there's evidence of oxidation reduction reactions, which are a source of energy, and there's evidence of organics. We've detected organics in situ with Perseverance rover. Those are the 3 ingredients needed for life. And if you found this rock on Earth, you would likely think that was a biosignature. It's an ancient one, it's an ancient rock, not modern life, but ancient. So we bagged this now, we've collected it. You're looking at the end of the sample tube there, of the drill bit, and that sample is now in the belly of Perseverance, waiting to come home for us to tear apart in Earth labs and answer this question about life on Mars. It's there waiting for us. Now our job is to go get it. And so let's talk a little bit about how do we lead that future. What are the things we need to focus on? And look, if I have one message for you, it's a time of change in our country. It's a time of change. It's going to be a time of change in NASA. I believe that. The one thing we must do is continue to do really hard things. Our job as a nation, in order to lead, is not to do what's easy. It's not to do what we can predict exactly how it's going to go and know how easy it's going to be, that we're definitely going to meet every milestone at every moment. Our job is to do the things that are ridiculously hard, that are so hard that sometimes they're hard to plan, right? Detecting, sensing Earths around other stars. It's ridiculously hard. Doing the first round trip to Mars, it's really, really hard. And you know what? We need to do it. Exploring into the oceans of a moon like Europa, holy cow, it's impossible. I mean, just like flying a helicopter on Mars, it's impossible. We did it 72 times. We can do these things when we put our minds to it, when we put our collective energies behind it. And so for the future, continuing to drive the forefront of getting to planetary surfaces. This is something that we have done at JPL. This is an actual picture of our Sky Crane lander for the Perseverance rover as it was set down gently on its 6 wheels on the surface and cut those bridles and fly away. It's one mechanism to get down to the surface of Mars. Landing on Mars is really stinking hard. That's why only a couple of organizations in the world have done it. One is China and the other is us. And we're proud of that history and proud to take it to the future. So as we look to the future of Mars sample return, we've got to go get those rocks. And so we have spent a ton of time and energy at JPL re-architecting, rethinking how we do Mars sample return. I could spend hours on this, but I'm not going to. NASA tomorrow is going to talk about the path forward there. We think there's a lot of exciting opportunities, both with industry and with the laboratory, to get these rocks back. This is our proposal, which is to use that Sky Crane technology that has so successfully landed the last 2 rovers on Mars, to get our big lander with a rocket on board down to the surface of Mars, load it up with those precious sample tubes, break that chain of contact, because that's always a scary part with Mars, the planetary protection. You got to make sure we're going to have those samples well contained and get them back to Earth as soon as possible. We've proposed something to NASA that would cut the cost to go of this mission in half over their prior estimate. We're really proud of that. That's the kind of innovation that we're driving for. NASA obviously has to make their decisions, and they're doing that, and we'll hear more about that tomorrow. But we're excited about what's possible here. And by the way, if we've got starships going to Mars, great. We'd love to put our lander inside of one of those. That would be great. So next, to follow up on the idea of exploring those ocean worlds and to finding life in the outer solar system, where it's harder to bring stuff back to our Earth-based laboratories, we've got to really make sure that we have autonomous systems that can be making smart decisions and exploring places that are unknown to us without our intervention, because they're too far away. So we've been investing at JPL in autonomous life detection capabilities for things like flying through the jets of Saturn's moon Enceladus. We've been investing in the next generation of robotics, this thing that looks like a snake, and it's called EELS, actually, and here's a little video of it. You can imagine a future lander, once we've discovered where it can go to access the ocean, sending our little snake robot down into their crevasse with its autonomous life detection capability on board. We've actually had a prototype of this robot out on glaciers, slithering down crevasses, very exciting new way of thinking about robot autonomy, because you're not talking to the Earth when you're down in one of these things. It's got to be smart enough to make its own decisions. And that's not just about the form factor of the robot. That's about the brains inside the robot. That's about the avionics and how it works and thinks. It's about flight computers. It's about innovating all of those things. And then lastly, if we want to go from the extraordinary leap that is our coronagraph instrument on Roman, that is 100 to 1,000 times better than any coronagraph ever built, that can see Jupiters. If we want to see Earths, it's got to be another 100 to 1,000 times better. This is incredibly difficult, and we are on the precipice of being ready to do that through a mission called the Habitable Worlds Observatory, whose real goal will be to find up to 36 other Earths, to find them and not just detect them, but actually sense the light from them, spread that light out into a spectrum, and analyze the chemistry of those atmospheres of exo-Earths. And how exciting would that be to be able to actually sense the photons? By the way, if you're staring at an exo-Earth, something like HabWorlds, you expect a photon, every 10 minutes, one photon. So this isn't just about making great optics or great wavefront sensing and control. It's about making the most sensitive detectors ever built. These things are incredibly complex, and I am just thrilled beyond belief to be able to represent the people of JPL who get to imagine these dramatic advances each and every day and then make them come to life. And so as I close, I will say, what we do, we love our work, but we do it for everyone, and we do it for humanity to be able to drive the forefront forward and to be able to drive rovers over the backs of little kids, like that middle one on the top is the funniest thing you've ever seen. Actually, you want to see kids laugh hysterically, drive a little rover over them. We're incredibly proud of the work we do, and we can answer the biggest, hardest questions if we dare mighty things together. Thank you. Okay. Now we get to hear from you.
Thank you so much, Laurie.
Okay. We doing Q&A here? That's how this works?
Very good, yes.
All right.
Yeah, we'll start with the Q&A right away. So perhaps we'll just continue with the Mars theme you ended on. You already answered one question, when is the Mars sample return update?
Yeah, it's tomorrow, supposedly. I saw the announcement just like most of you. Again, we hope to have these samples back by about 10 years from now. And I will tell you, as a Mars sample scientist, there's a running joke in that community that is Mars sample return has been 10 years away for 40 years. It's about 10 years away right now. Really hoping we can get that down to single digits pretty soon. So we're working on it.
Exactly. Wonderful. So here's a question that came up. What future JPL mission are you most excited about?
I love all my children equally. Well, I will say, again, I truly believe we have to do the hard things. I think MSR, one of the reasons it's felt like it's been such starts and stops is that it's really challenging. It's really challenging. And the thing I love about what NASA has asked of us at this moment is they've said, let's take some of the constraints off. Let's let you go innovate, you and industry, because there's a lot of pieces of this that industry can do, not all, but there are many. And we have been collaborating with essentially all of them on their ideas, which is our role as an FFRDC. We're excited to collaborate with industry across the board there. But so that's a really hard mission. And then I look out at Habitable Worlds Observatory, even though we won't be leading that. I think our friends at Goddard will lead it, but we will be doing the coronagraphy, the starlight suppression that actually allows us to sense Earth-like planets. I mean, that is incredibly exciting. It's going to take a long time to get there. We're still pretty far off in terms of the technology, but we have a path there, and we're excited to work on it with our colleagues across the country.
Mm-hmm. And I think in the spirit of collaboration, you talked about our collaborations with CNES on SWAT. Mm-hmm. There was a question about what other collaborations do we have with ESA?
With ESA, well, Mars sample return is a big one because we are going to go down to the surface and get the samples and get them up into Mars orbit. But what will grab them out of Mars orbit is a European-built orbiter called the Earth Return Orbiter, which will grab them out of orbit and bring them back either all the way to Earth or perhaps to cislunar space. There are a couple of options there where it'll drop them off and we'll bring them back down the rest of the way using that infrastructure that'll be there in cislunar. So there's a few options there. So Europe is an incredibly important partner there. We are working with a lot of the member states as well. We work with Italy on so many missions. It's hard to name them all, especially in Earth science, and also, I mean, there's an Italian radar orbiting Mars right now. It's just so exciting. We're working with Germany on the next version of our GRACE mission. Our GRACE project manager is here. Our gravity mission at Earth that allows us to see, it's amazing, the only Earth science mission that never looks at Earth. It just measures very precisely the distance between two satellites and how the gravity is changing as they go across different parts of the Earth. So partnerships are critical, and we're very excited about the ISRO partnership as well on NISAR because India is a relatively new partner for NASA. And their space program is growing by leaps and bounds, and they are hugely capable. We've had 2 to 3 dozen engineers over in India on and off for the last year and a half, and it's just been an incredible experience. They sent folks to JPL earlier in the mission. We send folks there now. That collaboration is so powerful. And so, again, watch for that launch in the March-April timeframe.
Yeah, that'll be very exciting. So a lot of aerospace companies, including JPL, have experienced layoffs and shrinking throughout the year. Mm-hmm. How can we as an industry continue to grow?
Yeah, thanks for that question. I know people have heard about our layoffs, and I appreciate that the press has been covering it and sort of wringing their hands right along with us. It's been a really challenging, 2024 was challenging. Here's one thing I'll say just to set the context. So JPL was bigger than it had ever been, I think. We were almost 7,000 people, and we had, there were a lot of reasons for it. We don't have to get into all the reasons, but we were really big. And we did have to go through layoffs, and that's rare for us, and it's painful, and we never want to have to do it. We are now at 5,500 JPLers, which is our sort of historical average. So we are now right-sized for the future, and I do not anticipate further challenges there. I think we did the hard thing that had to be done, and now we're ready to move forward and from an exciting place. And again, I personally think there's likely to be more Mars in the agency's future, and we are the experts on that within the agency. I think it's a good time for us to be looking to that future more positively. Look, I think we all should be supporting funding for space exploration, whether that you're on the DoD side, on the aeronautics side, on the space science side, or earth science side. We need to keep that funding stable. That's the thing that prevents the ups and downs. So for us, we're pretty focused on how we manage well at this stable level going forward, and we will be doing hiring more as this year happens, not to grow so much, but as we have attrition. And so if you're interested in working at a place like JPL, I do hope you'll keep us in mind as the year gets going.
Absolutely. There's a lot of interest, since you mentioned that Clipper is doing so well, about how Psyche is doing.
Psyche, thank you for asking about Psyche. I know there's too many missions, right? I don't have time. Psyche's doing great. It did its Mars flyby, I think, and it's thrusting, so they have an electric propulsion system, so they're in their thrusting phase now. So it's not too talkative during that phase. We just sort of hear from it occasionally, but really going well, looking great, on its path to Psyche the asteroid. So Psyche the mission is going to Psyche the asteroid, which is a metal asteroid. Really it's true exploration, our first visit to a metal world. Think about it, we visited rocky worlds and icy worlds and gaseous giants, but never a metal world. And so Psyche's gonna show us something we've never seen before, and that'll be in 2029 when it arrives at Psyche and goes into orbit for a long mapping mission. It's gonna be great. So yeah, Psyche's rocking it.
You know, so many great questions.
Or
I think
meddling it, I don't know.
Well, I'll try to squeeze in two last ones here. So how does exploring the moon fit into JPL's mission?
Yeah, thanks for asking that too. We love the moon. You know, we think of all basically bodies like that as planets, so you know. But we have a moon mission launching, it could be as soon as this month, as a ride-along with the IM-2, the Intuitive Machines 2 lander. Ours is an orbiter called Lunar Trailblazer. It's a small, inexpensive orbiter, but carrying some really cutting-edge spectrometer technology that's going to allow us to map volatiles like water from orbit all over the moon. And so it's going to be a really exciting mission. If you care about lunar resources, we really need more data on exactly where those are located and what their form is, and Lunar Trailblazer is an important piece of that. We're also, I will say, we are collaborating with SpaceX on their, and to some extent Blue, on their landed missions for the moon, where, you know, we have, we sort of are, in many ways, the keepers of the agency's expertise in landing on planets, and so we're trying to help anybody who needs it in thinking about how they land on other worlds. So we're working with SpaceX on the human landing system, just again supporting their efforts there, and talking with Blue Origin as well. So we're thrilled to work with industry on accessing the moon. And of course, again, if there's going to be more Mars in our future, we're excited to work on that as well.
Wonderful. And then finally, in our last minute here, a more personal question. So what is your geochemist opinion on the Vikings findings?
Oh, boy.
And how does that differ from what's been found by Perseverance thus far?
Oh, boy. Okay, going way back into the archives for that one. So Viking was a life detection mission. And I mean, first of all, huge props to the Viking. So we're coming up on the 50th anniversary of Viking, by the way. So we got to have a big party for that. A huge celebration. 50th anniversary of Viking coming up. 50th anniversary of Voyager coming up. And oh, by the way, I didn't talk about it here, but we still talk to Voyager every single day. It is beyond the solar system, the farthest flung human-made object. So for Viking, so came at a time when our understanding of the diversity of life, even on our own planet, was more limited than it is today. And so my view is they didn't detect any organics. The chemistry experiments found reaction, but it was probably chemical reaction in the soil. It told us that the very surface of Mars is a hard place to preserve evidence of life. You've got to drill into rocks. You've got to go find the right samples in order to do the analysis. And that's what Perseverance has done. And that's why we have to get those rocks back and bring them back on Earth and really tear them apart and understand them. And by the way, in case you're worried about it, a core the size of your pinky in labs on Earth could be sliced into 1,000 pieces and sent to labs on 6 continents. This is plenty of rock for us to work with in labs on Earth. And we won't have the confusion that arose from the Viking results. Still, a very important step forward, helped us understand the surface of Mars incredibly.
Oh, wonderful. Thank you so much. It's been such a pleasure to enjoy your remarks. And I'm just going to reach behind you briefly. So on behalf of AIAA, I'm really pleased to present this challenge pin to you.
Thank you.
So thank you so much. We really appreciate your
Charles.
being here.
Thank you all. Have a great conference.
And then I have one or two additional announcements to share with you before we close out the morning session here. So the technical program will begin at 9:30. So again, we encourage you to use the AIAA Events app to access the detailed program information. It also has the latest schedule. I've been using it myself. It's really great. We're going to continue the conversations today in the Forum 360 panel sessions, which will be in the Regency Q Ballroom. At 10 a.m., we're going to hear about aviation R&D requirements. Then at 1 o'clock, there will be a panel discussing mission requirements driving space R&D needs. So please don't miss either of those. And then at 3:30 later today, we have two really great choices for you to select from. We have the AIAA Duran Lecture for Public Service. That will be given by Kevin Bocut from Boeing on the evolution of hypersonic flight over 7 decades and the technical breakthroughs that got us here. And also NASA Aeronautics will host a session on ushering in the third aerospace revolution, status from the U.S. Advanced Air Mobility Interagency Working Group. So once again, thank you very much for joining us this morning. Enjoy your time here at SciTech, and I look forward to seeing you across the meeting and in exhibitions and throughout the day. So thank you very much again.